In this lesson, we are going to be looking at solving multi-step equations. So if you remember from lesson 1.1, we learned about the subtraction property, addition, multiplication, and division properties of equality. And we are going to use those same properties today to solve two-step equations. So to solve multi-step equations, use inverse operations to isolate the variable. So we're going to start off fairly easy with the equation 1.5x plus 15 equals 24. And of course, that's always going to be the first step, is actually writing the equation. And now we need to figure out what is currently happening to this x, and we need to try to get it by itself. That's the ultimate goal here. So I'm going to take the 15 away first from both sides, because remember, as this was initially, it was a perfectly balanced equation, so we can do pretty much whatever we want as long as we do both, or the same to both sides. So I end up here with 1.5x equals 9. And now I'm down to a one-step equation that we saw in the last lesson. So now I can see that 1.5 is being multiplied by x. To undo that, I need to use the division property of equality. Divide by 1.5 to get x essentially by itself. Divide by 1.5 on the other side. And when I simplify, I will get x equaling 6 for this problem. Moving on to something just slightly more challenging. In this case, I've got 8x minus 6x minus 25 equals negative 35. So in this problem, I'm going to have to combine like terms in order to solve for that equation. So the first thing I have to recognize is that I have two terms here that are similar. And so I need to combine those two before I do anything else. So if I have 8x's and I take away 6x's, I am left with 2x's. And then of course I rewrite the rest of the equation because I don't want to get lost in my steps. And now I'm back to kind of where I was up here in the beginning of this one. Now I can see that I am multiplying x by 2, and I'm also taking 25 away from 2x. So I want to combine these like terms here by getting rid of the 25 first. So get rid of the 25 and add 25 to this side. That essentially gets rid of that one. 2x equals negative 10. And now I'm to the point where it's just a one-step simple equation. Just to simplify, I need to undo this multiplication by dividing by 2. And I've got x equals negative 5 when we simplify it down. All right, third example is using the distributive property to solve an equation. So we are going to solve for 2 on the outside of the parentheses. And the rest of the equation is 1 minus 5x plus 4 equals negative 8. So in this case, I need to take the value of this 2 and I need to distribute it through to the 1 and distribute it through to the 5x. So when I kind of compile this, I can actually see that it will end up being 2 times 1 minus 2 times this 5x. So I basically undid the distribution there so we could see what it was before we had put it into that format. Plus 4 minus 8. And of course the 2 doesn't go any further than the 1 and the 5x because that's where the parentheses end. So now take your 2 times 1 and you get 2. 2 times 5x is going to give you 10x. Plug that 4 back in. And that negative 8. So we've got some like terms that we need to be working with here. I have positive 2 and a positive 4. and then I have that negative 10x. I'm going to go ahead and write that negative 10x down first. Combine the 2, combine the 4, just like we did in problem sample 2 to get 6. And rewrite the equation. And now I'm combining these like terms here. I'm going to take this 6 away, which means I take 6 away over here. Always trying to get x by itself. And we've got, so far, negative 10x equals negative 14. To get x by itself, I need to undo this multiplication by dividing by a negative 10. And dividing by a negative 10. And I'm going to get x equals a positive 1.4, because as we know, a negative divided by a negative gives you a positive result. Alright, so now we move into some trickier real-life application problems. So these I've actually printed off onto this paper here. So we're going to use this table to find the number of miles, which are represented here by x. You need to run on Friday so that the mean number of miles run per day is 1.5. So you can see that in this chart, Monday we ran 2 miles, Tuesday they ran none, Wednesday 1.5 miles, Thursday none. We need to know that if our goal is to run an average or a mean number of miles that is 1.5 per day, I need to know how many I need to run on Friday. So I'm going to write an equation using the definition of mean. So I'm going to take the sum of all of my data, including this unknown, 2 plus 0 plus 1.5 plus 0 plus x. And yes, I have to include those zeros because they, even though they have no value in terms of being a number, they have value in terms of being a data point. And then I'm going to divide all of that by 5. 1, 2, 3, 4, 5 pieces of data. So that's the number of values I've got. And all of this is equal to my mean that I am trying to get to, which is 1.5. So add up all the data, divide by the number of data points, and you want this to be equivalent to a mean of 1.5. So I'm going to add up all of my whole numbers to get 3.5, and then of course I'm left with this x, and still being all divided by 5, and still trying to get the equivalent of 1.5. Now start undoing what is currently being done here in this situation. Let's take care of this division by 5 first, by multiplying by 5, get rid of that, to end up with 3.5 plus x equals 7.5. And since this is a positive 3.5, I can undo that by using subtraction, and undo that over here by using subtraction. Get rid of that. X is equivalent to a positive 4 miles. So you would have to run 4 miles on Friday to get an average number of miles run per day of 1.5. So those are probably the trickiest problems you're going to see in this lesson, so we're going to look at one more. So you've scored 88, 92, and 87 on 3 tests. We need to write and solve an equation to find the score you need on the 4th test so that your mean test score is 90. So if you're really hoping for that mean average test score of 90 so you could get that A minus and not that B, what do you need to get on that 4th and final test? So we are going to once again add up all of our data, 88 plus 92 plus 87, and include that unknown. We have 4 data values, so I'm going to divide at some point, or at least show it in my equation that I'm going to divide each of these by 4. And I want this to be equal to 90. So when I add all of these up, I get 267 plus x equals 90. Oh, don't forget that that's still all over 4. And now, just like we did in the last one, we're going to start undoing the division by multiplying by 4 and multiplying by 4 over here. That gets rid of that. 267 plus x is equivalent to 360. You take away your positive 267, take away your 267, and you are left with x equals 93. So if you were wanting to get that 90% for your mean average tests, you would need to get a 93 on that fourth test to come away with your goal of 90.